Okay, here's warm-up number 46. Use logs to determine how long it would take for $4 to be worth $2,000 if invested at 8% annual interest. Okay, annual interest, so we're using y equals a times 1 plus r to the t. You could use the one with the n's, but the n's are just going to be 1, so it'll simplify to this anyways. Okay, so let's start putting stuff in. 4 is my initial amount, that goes here. 2,000 is the final amount. Okay, my rate is 8%, and you want to write that as a decimal, like so. And the time is the piece that we don't know here. Okay, so let's start simplifying. Okay, next up, don't multiply 4 times 1.08 because they have different exponents. What you want to do is divide both sides by 4. So then I've got 500. 500 is going to equal 1.08 to the t. Okay? Now at this point, this is where I need logs. I simplify as much as I can without logs, but now I've got a variable as an exponent. So only way to isolate that is using logs. So my base is going to be 1.08. 500 is going to be the contents of the log, and then the t gets isolated. Okay, and then I'll put that into my calculator as log of 500 over log of 1.08. Make sure to close the parentheses in the numerator. Okay, and I'm going to the nearest hundredth of a year, so I'll call that 80.75 years. Long time, but you know, $4 turning into $2,000. That's why that's taken so long. Okay, next up, we're going to graph this equation. All right, so I'm going to use the y-intercept and the horizontal asymptote. The horizontal asymptote is just going to come from this. So it's going to be y equals whatever that number is added or subtracted. So it's going to be the line y equals 1. If there's no number out there, then it's the x-axis, but y equals 1. Here is my horizontal asymptote. Okay. Now I can see that this is going to be exponential growth because my base is more than 1. That I'm looking at the 2 there, that's the base. So it's going to curve upwards. So I'm just going to find the y-intercept, and then I'll make a curve that kind of fits this asymptote and the y-intercept. Okay, so the y-intercept, I'll find that the way I always find y-intercepts, by plugging in 0 for x. Okay, anything to the 0th power equals 1. So then I've got 3 plus 1. 4 is my y-intercept, so that's where my curve is going to cross the y-axis, okay? And then it's just going to go uphill, kind of an uphill curve. It's not going to cross over this green line. And if you wanted to get more accurate with exactly how it looks, you could plug in some other x values. But generally, that's going to get an exponential curve with this floor that's going to cross the y-axis there, okay? All right, now let's find the equation for the inverse of this function. So first step is to take this equation and switch the x and the y. So I'm going to write x equals 3 times 2 to the y plus 1. Okay, and I'm going to start solving this for y. So I'll start by subtracting 1 from both sides. Okay, don't simplify this into 6 to the y. You can't do that. Okay, next thing I want to do is divide by 3. Both sides of the equation by 3. Then those cancel each other out, right? So now I've got x minus 1 all over 3 equals 2 to the y. Oops, 2 to the y, like that. All right. And now to get the y isolated, I'm going to have to use log form. It's the only way to isolate an exponent that is a variable. All right. So my base here is going to be 2. The contents of the log is going to be the fraction. When I've got a fraction as my contents, I like to put them in parentheses so it doesn't look like 23 is my base. You know, it just gets confusing if the 3 is part of the base or not if you don't use parentheses. And then the y is isolated, and that's my inverse. Now I'll just put it in function notation. Okay, you could write the contents as x over 3 minus 1/3. That would be the same thing, equivalent. Okay. All right, so now let's graph this. All right, so graphing this, there's two ways you can do this. Let's just use this though. So if you remember, so exponential functions are going to have a horizontal asymptote. Log functions are going to have a vertical asymptote. And since this is the inverse of that one, I can just think, okay, if that was y equals 1, then I'm going to have x equals 1 as my asymptote here. Okay, and maybe you remember from earlier in the year, we have the point 0,4 here. So its inverse should feature the point 4,0. Okay? And then this is still, my base here is more than 1, it's 2, so I know it's going to be going uphill from left to right. So this is, it's going to be a curve. It's never going to cross over that green line, and it's going to cross the y-axis over there. Okay? All right, and then this last one, solve this. Sometimes I try to write both sides with the same base, although I don't think I'm going to be able to do that here. So I'm going to have to use log form. Let's do the log form so that we can isolate x minus 1. Okay, so my base is 3. The contents would be 72. The exponent gets isolated there, x minus 1. Okay, and so I'm going to have log base 3 of 72 plus 1 is going to equal x. A lot of times I'll see people combine the 72 and the 1 to say log base 3 of 73, but you can't do that. This is its own number. 1 isn't inside the log. The parentheses show me that. Okay, so I'm going to have to solve this part first. So let's see. I've got log. I'll type that in as log of 72 over log of 3. That gives me about 3.89. Okay, and I just add 1 to it. So it's going to be about 4.89. And there we go. All right, that's it. See you next time.